In this question, we want to use geometric properties to determine the values of x and y in the diagram. The important part of this question is to justify our thinking by using calculations or describing geometric properties or definitions that we used to come up with the angles. So let's start with the triangle at the top. We know that the sum of the interior angles in a triangle is 180 degrees. So angle y plus 80 degrees plus y equals 180. I know both of the angles here and here are y because it's an isosceles triangle. Looking at the pictures, I see these little tick marks, and those tick marks mean that both of those side lengths are the same, so it's an isosceles triangle. So there's 2 y's total, and we want that to equal 180 minus the 80 degrees. So that leaves us with 100 degrees for the 2 y's. And if we split that in half, or divide by 2, 100 divided by 2 gives us y equals 50 degrees. So that's a really good way to justify your answer for how you found y. So that calculation, I'm just going to move here. Into my justification section in my table. So y is 50 degrees. And if I wanted to use some definitions there as well, both angles that are missing are y, since the triangle is isosceles. So that's my reason for how I knew that these were both y. I also know that the sum of the interior angles in a triangle is 180 degrees. But the most important part there was the calculation that I did at the beginning. Okay, so now we're looking to find angle x. So I see a polygon, and what I want to do is, if it's not a triangle but has more sides, so this has 5 sides as a pentagon, I have to see how many triangles by drawing diagonals I could fit inside that pentagon. So I'm going to pick a corner. I'm going to pick this corner up here, and I'm going to draw with my highlighter 2 diagonals. Diagonals are from one corner to any of the corners that aren't right next to that corner that I picked. So I couldn't go from here to here because this corner is right next to the corner I picked. And I can't draw a line or a diagonal from here to here because this corner and this corner are right next to each other, or we say that they're adjacent to one another. I can, however, draw a diagonal here and here. And what that does is it creates 1, 2, 3 triangles. And luckily, we just found out in the first part of the question that the sum of the interior angles of a triangle is 180 degrees. So if we have 3 triangles, 3 times 180 gives us 540 degrees. And that's going to be the sum of the interior angles in the pentagon. So I'm going to leave that calculation there as part of my answer. And then the next thing I want to do is figure out, okay, so if I know that they have to all add up to 540, all those interior angles, and I've already got a few angles listed, in order to find the other angles, which are the same because they're both called x, I'm going to take 540 and subtract the angles that I know. So I'm going to take 540 degrees, I'm going to subtract 86, another 86, and another 102. And that's going to leave me with 2x, because that's what's left over, are the two angles both labeled x. So I've got 540, and I'm subtracting 86, and another 86, and finally 102. Those are the angles that I knew, and I'm just going to subtract them off of the total. So that's 266. So 2x equals 266, which means that 1x is going to be 133 degrees, because 266 divided by 2. So x is 133 degrees. And so that's using the sum of the interior angles in the pentagon and the angles that are already given.